This is a short video to show you the modifications that I made to my clutch basket in an effort to eliminate the chutter that I've been experiencing. I have a 2005 DL1000 that has about 20,000 miles on it. I bought a new clutch basket from Suzuki, and one of the first things I did was drill some dimples to match mark the parts so that I could get them back together in the same orientation that they came apart. So I'm starting with a brand new clutch basket here and making the modifications to it, and I'm going to swap it out with the chuttering clutch basket to minimize my downtime for the bike. I wanted to make sure to get the springs back in the same spring pockets that they came out of, because I understand they have some progressive nature to them. I know that if I get them back in the same spring pockets, they'll probably perform the way that they originally were intended to. The next thing I did was drilled the rivet heads off so I could start disassembling the basket. Once I got the rivets drilled out, I was able to pull the upper spring plate off and pull the springs out and put them in bags that were numbered corresponding with the spring pockets that they came out of. Had to remove these two Belleville washers and put them in the bag with the springs so I could put it back on when I reassemble it. This is the surface of the bearing on the primary drive gear as it came from Suzuki. You can see it's machined and has marks in it, and it was never ground or polished to run on a bearing. I'm going to polish this surface and bore the center of the clutch basket out and put a bronze bushing in there and try to reduce that clearance to a minimum. Right now it has about 12,000, so I want to get it down to about 1. So this is the surface of the bearing on the primary drive gear after I polished it. I took about 1/1000 of an inch off, taking the marks out of it, but it'll be a good surface to run in the bearing now. Then I pressed the rivets out of the bushing, so you can see I have 3 deep well sockets underneath there supporting the bosses right around the rivets when I press them out to minimize damage to the clutch basket. It took a little bit of force to get them out. These are all the parts that I plan on installing it back together with. When I took this photo, I was going to use the shoulder screws, but I opted to use 5/16 24 grade 8 bolt in place of those. When I measured the holes after I pushed the rivets out, it was the size of a tap drill for a 5/16 24 helicoil. So I switched up the bolts then, and I'll put hollow dowels in to fix that upper plate to the clutch basket rather than just relying on the torque of the bolts to hold it in. Here's the bushings that I made to go around the bosses on the clutch basket. I made those a slip fit on the bosses, which ended up being about 672 diameter. I measured the holes in the spring plate and they were about 752, so I made them a press fit in that, so they're pressed into the spring plate. This is to help minimize the movement of that inner plate, which is probably one of the primary causes of the clutch chutter, is having that inner plate able to move and resonate at the frequencies that occur right around 3,500 to 4,000 RPMs. You can see I also drilled 3 holes in the V-shaped webs on there, and I'm going to put a stainless steel solid rivet in there and buck the rivets over into those countersinks that I put the inner clutch plate. So this will give the inner clutch plate 3 points of fixation that it can drive the clutch basket and fix that all in place. I also cut windows in the bushings that I put around there, because the primary drive gear needs the clearance to have the range of motion that it had before, because the posts kind of act as stops for the gear when they compress the springs to the point where the spring's going to become coil bound. So here's my 5/16 24 grade 8 bolt with the hollow dowel on it, and I've reamed the hole in the boss and the clutch basket, so that is a running fit in that, and I've also reamed the hole in the outer clutch plate, so that will effectively pin those together so that all 6 degrees of freedom will be limited. So this is how the screws are going to fit in when the outer plate goes on. Next, I installed the locking helicoils in the holes that I pressed the rivets out of, tapped them, and installed them in. You can see the whole helicoil down in the hole. This is kind of what it looks like from the back side. And then I mounted the clutch basket up on a lathe and bored the center out for my bushing. I bored the center out about 100 thousandths larger than what it needs to be to run on the primary drive gear bearing. So this bushing has about a 50 thousandths wall. Then I pressed the bushing in and put Loctite bearing retainer on it. That should stay in for a good long time. Here's the inside of the clutch basket where I put the rivets in. They're flathead rivets. And here's the bucktail of the rivet bucked over into the countersink I put on the other side. There's 3 of these in. And this is the plate fixed down to the clutch basket with the rivets and the bushings. This is with the gear installed, and you can see how the pockets provide clearance for the gear to the original factory clearance, so the gear can move over and hit the post to stop when it compresses the spring the right amount. Next, I installed the springs back into the spring pockets from the bags corresponding to the numbered pocket. Then I put the 5/16 24 bolts in and torqued them to 20 foot-pounds. Here's the inside of the clutch basket when it's finished. I laid a straight edge across the outer spring plate, spring pockets, to make sure that the heads of the bolts didn't protrude beyond the spring pockets so that they would interfere with any of the other components when the clutch basket rotates around. And it looks like it's ready to install.